Uh, Hello everyone. Today we'll try to do some numericals uh, today we'll do some numericals and conjugate beam method. So we need to find out the deflection of the beam by using conjugate beam method. So conjugate beam method. So we'll do some numericals and conjugate beam method. So to find out slope and deflection of the beams by using conjugate beam method, let us take one numericals. So what is that? So for the cantilever beam, shown in figure, compute deflection and slope at one at the free end, second under the load, and we also need to find out what is the slope and deflections under the load. Here take EI equals to constant. Here you take EI equals to constant. So let us consider. So this is the given figure. So this is a given problem. So there, what is this? How much is a 50 kilonewton load is acting? 50 kilonewton load. This is 3 meter and this is 3 meters. So let's say this is point B, this is point A, this is point B and this is point A, and let us take this point is C. Your first step is to, in conjugate beam method, draw the BMD for the given problem. So now let us draw BMD for the given problems. You already know that how to find out the BMD for the given beams. So here we can see here what is the bending moment A point. Bending moment point A is 0. Bending moment at point C is also 0, and bending moment at point B is maximum. So that we need to find out. So now what is the bending moment at B point? Bending moment B point will be 50 into 3, so it is 150 kilonewton meters. So it is 150 kilonewton meters. So 150 kilonewton meters, how it is came? So it is 50 into 3, that is 150 kilonewton meters. It is a minus because it is hugging, so it is BMD. Now draw the conjugate. Next step is to draw the conjugate beams. So now let us in conjugate beam method, so the BMD diagram is taken as the loading for the conjugate beam. So let us say this is datum, and this is datum. So in conjugate beams, BMD will be taken as the loading for the conjugate beams. So this is the BMD. We need to take loading for the conjugate beams, and this is point B, this is point A, and this is point C. This is 3 meter, and this is also 3 meters. So now, and it, how much it is? It's 150 kilonewton meters. Please remember, in conjugate beams, wherever the fixed end is there, we need to make it free, and wherever the free end is there, we need to make it fixed. So at point B, in actual beam, it is fixed, so make it free, and in point A it is free, make it fixed. So it's a very important point we need to remember. So now next we need to find out what is the slope and deflection at the different points. Now let us say we find out what is the slope at the point A. So slope at point A, so it is conjugate beam, beams. So whatever in conjugate beams, whatever the BMD is, their value they should be divided by the EI. So that is should be divided by the EI. So here you can see throughout the EI, throughout the beams, EI is constant. So take 150 divided by the EI. Please, is a very important point. So we need to remember. So BMD should be BMD divided by the EI. So in throughout EI is constant. EI is constant. So EI is constant. So I will take it as 150 divided by the EI. So it's a very important point. Whatever the BMD value is there, it should be divided by the EI. That's why it's called M by EI diagram. So that's why sometimes it's called M by EI diagram. This is a M by EI diagram. So, and this is the conjugate beam. This is the conjugate beam. So now you find, if you want to find out the slope at the point A. So let us say find out the slope at the point A. Then slope at point A. So theta A in real beam, that equals to the shear force at A in conjugate beam. So please, a very important point. So if you are finding if you want to find out the slope at point A in real beam, slope at point A in real beam, that equals to the shear force at A in conjugate beams. Please remember here, so whatever the load or force that equals to the area of that M by EI diagram. So M by EI diagrams. So please remember, load or force that equals to the area of the M by EI diagrams. So then shear force, you already know what do you mean by the shear force is algebraic sum of the vertical forces taken with some cross sections. So now let us find out what is the slope at the point A. Then theta A equals to what is that? Shear force at A in conjugate beam. So shear force at A in conjugate beam. So what is the shear force at A? Algebraic sum of all the vertical forces. So you already know that in shear force you are coming from left to right, upward is positive, downward is negative. So here you can see, let's say is acting upward. So upward. So we need to take the what is the shear force at point A. So you need to calculate what is the shear force at point A. So we need to do algebraic sum of all the vertical forces. How many number of the forces are there? That force equals to area. How many area is there? Only one area is there. So it is half into what is the base? Base is 3. What is the height? Height is 150 by EI. So 150 by EI. So it is how much it is? It will be 225 by EI. So it's a very important, we need to remember. So this is how we need to calculate what is the slope at required points. So similarly, if you are finding what is the slope at point C, let us say you are finding slope at point C. So what is the slope at point C? Slope at point C is the what? Slope at point C in real beam, that equals to the what? That equals to the shear force at point C in conjugate beam. That equals to the what is that? So what is the shear force at point C? So how many number of the forces are there? Only one force, that is the only one area is the triangle. So what is the triangles? Half into base is 3. What is the height? Height is 150 by EI. So it comes to 225 by EI. Very simple. This is how we need to find out what is the slope at the different points. Now let us find out what is the deflections at the different points. So deflection. So now as per the problem what they ask, so what is the deflection at point C? Now let's find out what is the deflection at the point A. Deflection at the point A in real beam, that equals to the very important, that equals to the bending moment at A in conjugate beams. Bending moment at A in conjugate so beam. So please remember guys, this is very important. If you are finding at any point, so this point should be remembered. So what is that? Deflection at point A in real beam, that equals to the bending moment at A in conjugate beams. So means, or if I will write in words. So deflection at A in real beam, that equals to the bending moment at A in conjugate beams. So conjugate beams. So now let us find out what is the deflection at the point A. Deflection at the point A, that equals to bending moment at point A in conjugate beams. Then so conjugate beams. So delta A, that equals to, what is the bending moment at point A? Bending moment at point A, what is that? So we need to find out what is the bending moment at the point A. So what I have to do, we need to find out area into force into distance. We need to do it. So what is the force here? Area is the force, and central distance up to here we need to consider. Up to here distances, force into distances we need to consider. So we already know that up to here we already know it's a what, 2/3 of 3 it is. So here to here 3 it is there. So let's find out what is the deflection at point A. So what is the deflection at point A in real beam? That equals to bending moment in conjugate beams. So what is the force? Force is half into base is 3. What is the height? 150 by EI into, what are the central distances? 2/3 of 3 plus 2/3 of 3 plus, so 2/3 of 3 plus it is 3. So 2/3 of 3 plus remaining distance, it is 3 meter is there. So it is 3. 2/3 of 3, so plus remaining distances, so it is 3. So how much it will be? It will be, once again guys, so it will be, how much it comes to? It comes to 0.5 into 3 into 150 into into, it is 2 plus 3, it is 2 plus 3, so it is 1125 point EI. So it is 1125 point EI. So it is 112.5 EI. So it is 2.5 EI. So it is there is a, what is that? This is delta A. Similarly, we need to find out what is the delta. We need to find out what is the deflections under the load. We need to find out what is the deflection under the load. So deflection under the load in real beam, that equals to the bending moment at C in conjugate beams. So what is the bending moment conjugate beams? So it is, if you are finding bending moment the conjugate beams, so of force into central distances. What is the force? Force is half into base into height, and it is 2/3 of 3 into 3. So 2/3 of 3 into 3. So it is comes to be how much it is? It is comes to be 450 by, it comes to be 450 by EI. If it comes to be 450 by EI. So that's how we need to find out what is the slope and deflection at the different point by using conjugate beam method. Guys, please, you need to remember here. So what is that? If you are finding slope at any point, that is in real beam, that equals to CA force in conjugate beams. So that's we need to remember, is a very important while doing the while doing conjugate beam method. Okay, so now, so guys, please so now let us consider another example. So for better understanding, we'll do another example. So another example, so let us consider this, a beam subjected to, so let us consider example 2. Also, a beam, it is subjected to a UDL throughout its length, is subjected to UDL throughout its length. So what is the load? Load is 10 kilonewton per meters. So how much the length?